Well, welcome back. Apologies that we're slightly behind schedule for this session. We are 15 minutes behind the advertised time, so apologies for that. We had a good discussion in the last one, but we are now moving into the final session of the opening plenary day. We have two separate parts to this, but and also some varied content within this. The first one is really around digital twins, and as we know, this is a really hot topic in our industry, and we have two fantastic keynotes who'll be giving their perspective on that. And then we move into our partnership slide, which is always a feature of buildingSMART's keynotes, which shares existing partnerships and potential future partnerships that we might want to develop. Yeah, some really exciting things to share around that as well later. So I won't delay proceedings any further. I'd just like to introduce Jennifer Lin, who is the Chief Platform Officer of Trimble, and she'll be providing a perspective from Trimble themselves. So with that, I'd like to hand over to Jennifer.
Hello, everyone. I'm thrilled to be here today. My name is Jennifer Lin. I'm currently SVP and Chief Platform Officer at Trimble. And I'm thrilled to spend time with you in this keynote today talking about digital models and industry collaboration. I'm a recent add to Trimble. My role at Trimble brings together a number of things I've done in my career. Way back when I actually worked on interactive 4D CAD models, it was during my graduate school days for research that was funded by Intel, who at the time as an owner was building out large 1 million square foot fabs, clean rooms, and assembly test facilities, and really needed better tooling to manage essentially that asset all through the design, construction, and operation phases. That's a great example of a very complex system. We were actually applying the time overlay, the project overlay, design data as metadata to physical CAD models, but this was very early on. After that, I went to work for 12 years at Cisco and did some startup work along the way, but spent a lot of time in the network and mobile communication space, both physical routing and switching, as well as mobility, location services, and Wi-Fi for enterprises. That controller-based architecture really unlocked sort of a new model of how folks accessed data through their mobile devices. And after that, split off to do a startup that got acquired by Juniper Networks. As Contrail, we were working on software-defined systems for customers like AT&T Mobility and Riot Games and Workday, who were really building out sort of SaaS-enabled systems as they moved to their cloud model. After that, I ended up at Google Cloud, leading product and UX teams as we were thinking through B2B platforms, primarily as these vertical industries like financial services, retail, and manufacturing, healthcare, were moving to the cloud and really leapfrogging, not just moving their infrastructure, but thinking about data analytics and machine learning and delivering a better user experience and hiding a lot of the complexity of the industry components. So as we've seen, as we've moved from 2D CAD to BIM and more digital construction with data overlays, this is really more about a data journey. Trimble has had this mission statement of connecting physical and digital worlds really for traditionally underserved industries, construction, agriculture, and transportation. Geospatial technologies, the company was really founded by Charlie Trimble using satellite positioning technologies, and geospatial technology is also at the heart of good digital twin modeling, really applying that location and spatial awareness to objects, processes, relationships, and using that within an advanced data framework to represent the Earth's surface and show layers over time. This was well before GPS was a consumer level technology, so it really required a lot of strong engineering. And originally, geospatial technologies and digital twins were used by NASA for simulations to improve very complex systems orbiting in space. I think the consumerization of those types of concepts has led us to the notion of constructability, where we can really apply connected data a lot of the data is now coming off of not just sort of user inputs, but also machine controls, other sensor technologies in the field, as well as data that is captured for specific components and content data for systems like MEP. The ability to put that data and represent that data digitally throughout the prefabrication, fabrication, and construction process leads us to more rich model technologies and workflow, connected workflows, really thinking about how do we have accurate data and real-time collaboration, because that's often the missing piece in avoiding a lot of the mistakes and rework and guesswork that goes on in the field. Industrial systems have kind of moved from very linear handoffs and very hierarchical proprietary systems to more digital delivery, and cloud has been a huge catalyst for that. Cloud enables elastic capacity, global reach, ability to localize and personalize content at the point of delivery, and deliver better user experiences and better on-demand interactions. There's three major components to that: better shared data, and in this case, shared models, richer stakeholder engagement, and better application and user delivery of that data, and then common system view and sharing and transparency across these connected workflows. The ability to deliver that data both synchronously and asynchronously, a lot of the challenges have been about how do we enable a broader shared model, but federate the data to make sure that each set of users is empowered to do what they need to do. Trimble uses this notion of constructible models and really domain intelligence. This is how we represent a source of truth for the data at every stage. Primarily, the build phase in a connected construction site really has to fuse together the design intent and the expectations in the life cycle of how that asset will be operated. Not only is that a broad set of data that is shareable, but it needs to be served up to the actual domain so that whether it's an owner needing the data or real-time updates, or the general contractor that's trying to coordinate a number of specialty contractors, this notion of there is no one single model to rule them all, but more distributed and federated data that comes together in the broader system. Spatial anchors is something that Trimble worked very closely with Microsoft. Really, how do we take spatial awareness and ground it to digital models within the physical reality? So the notion of spatial anchors we've done as a mixed reality technology where we can perceive spaces and designate markers at precise points of interest in the physical world. This really also helps create visual anchors. So someone in the top right there, you see someone wearing the lenses. We had a product from Trimble called the XR10, where we used our Connect collaboration technology with Microsoft HoloLens technology to bring together an experience for a user in the field where we could improve the precision and accuracy of the data model overlay and really coordinate and optimize performance in the field. It was originally done for training purposes, and now really even for expert users, the ability to get the data at that point of work is super efficient, avoids a lot of rework, et cetera. The key is really how we handle that federated data, understanding who the user is and what data they need, and the contextual data that is needed for situational intelligence. So that once again, this moves us from linear hierarchical handoffs to more coordinated contextual information at the application and user level. So now that we have sort of understanding of who is the user and what data do they need, this is really bound together at the level of workflow orchestration. So workflows orchestrate the data and the users at a point in time, enabling both bidirectional data flows as well as iterative engagement models and a closed loop where we can constantly check what is the desired state or the design intent to what is the actual physical conditions. This is also leading to how we generate more effective as-built information as an extension of the actual design models. We can really manage exceptions. We can also manage change at the level of composable objects whether those are model objects or content or asset inventory data. Trimble recently acquired Agile Assets, who has been using digital twin technology for things like, roads and bridge inspection and better preventive maintenance for the physical world. Key thing here is that the delivery model also changes to everything as a service, and this is once again where cloud technologies are most desirable in that world, where a lot of the underlying enablement is hidden from the end user. The key thing, once again, is how do we enable more transparent and continuous interactions, delivering data in real time at the point of work. This does require a more system level view defined as data and software and a structured collaboration model, as well as better change management. If you think about source code development and how distributed development teams coordinate sort of software delivery to a release, things like Git-like change management in a Git repository, each stakeholder can check in essentially changes that are inspected and approved, and it comes together as a broader release system. The pace at which this is changing is happening faster and faster, to the point that you can no longer have a human in the middle of that. So these systems need to be more contextually aware, more application aware, and the systems need to become more programmatic. As each individual stakeholder has a better understanding of the broader system, we can not only build better trust and transparency as an ecosystem, but accelerate learning. This is learning both by users as well as by the system. But the data consumption has to move from more published snapshots of data to more open data formats like IFC that are exchanged, and then each individual can apply more granular metadata attributes for differentiating their delivery. The metadata has to feed into increasingly automated machine learning layers, and at that point we can build and train better models. You have to be able to deliver and share those models, but you have to be able to start with the right data at the right time, at the right level of accuracy. And this is where this is not something that a startup can do overnight. This really does require a lot of domain intelligence, a lot of precision accuracy, and a broader understanding of how these systems, both human and machine systems, can come together. It also requires a different model of interaction and continuous verification. So on the left, you may have an engineer making an update to a design, checking that design in against either published standards or native standards, but essentially that needs to come together to actual constructible models in the field. At the same time, if there's a problem in the field at the edge or the site, that data needs to be reflected. Changes need to be incorporated back as-builts to update the design, which becomes obviously an asset in the inventory of the day 2 operational lifecycle. These types of models are well known in other industries and cloud-enabled ecosystems, and this really has required an understanding at the industry level of how those common abstractions and best practices can be shared. Once again, everybody has to be able to manage exceptions, not capture value in a lot of the repetitive work. Now, building systems to anticipate change and come together essentially as an ecosystem is really a different lens on the industry. At the same time, these connected workflows and data services need to be orchestrated in a way that is grounded at the project level. This is something that can't be defined up front, but it allows us to deal with more real-time changes, whether that be supply chain shortages or pricing changes, or how do we move a lot of the goals of sustainability and project optimization upstream so it's not rework at the later stages of design or construction. Publishing these models both at the system level as well as at the component level, and building in real-time feedback loops and better communication systems really also modernizes the user experience. We can hide a lot of the complexity of the underlying technology and really think in a different way about how we can safely and productively embrace automation and enable better collaboration. Again, sort of these supply chain type issues or modernized commerce is really a way to build trust and transparency and build into construction and delivery a lot of the capabilities that are pretty commonplace in other industries. What is very unique to construction are the things that are necessary in outdoor project level environments. And this is where a lot of the domain intelligence can be built into the upstream stages, and we can safely automate the entire lifecycle process. So there's a lot of complexity, but I'm very bullish as we build more extensible models for what is to come for the future, as opposed to automating tasks that have been done a certain way historically. We can take on much more gnarly problems, as well as evolve the incentives to be more carrot versus stick, and not just managing risk, but really thriving with a growth mindset. Publishing these models and best practices across the industry also helps us just modernize the industry and digital app delivery. I think it not only helps us recruit the next generation into the industry, but it also unlocks a lot of the creativity and safe experimentation that we're going to need to tackle a lot of society's biggest challenges moving forward that will fall on the design and construction industry to take on. So thanks very much for joining me today. I'm really thrilled again to address the buildingSMART community and look forward to working with you as we take on this journey ahead. Please feel free to contact me at any point, and look forward to seeing you in the future. Thanks very much.
Well, thank you, Jennifer. That was fantastic, really interesting insights, and we look forward to certainly working with Trimble and developing some of these collaborative models that are being developed at Trimble. So yeah, that was fantastic. Well, next up, we have a presentation from Bhupinder Singh, who is the founder of InTwin. Bhupinder has been was at Bentley for 26 years. Is that right, Bhupinder? Yep. We're former colleagues. So I appreciate connecting, and you're also assisting us with the development of a chapter in India. So yeah, it's great that you've taken some time out today, and we're really interested in your perspective on digital twins. So yeah.
Yep, it was great. Thank you. So listen, it was great to hear about what Jennifer had to say with Trimble, and all the software vendors are eagerly looking at digital twins as an answer, and I thought I'd start with the problem. And the data that I'm presenting here is actually before COVID, so they haven't been updated with what's happened since then. But if you just take approximately that the numbers from a growth standpoint is about this, the overall point is the world is going to need about the equivalent of 6 Europes for giving the new entrance into the middle class a quality of life that frankly they deserve, and everybody does. So, and let's not forget, we're talking about this in the context of inflation today and deglobalization today, which is going to make everything more expensive, and I believe everything is only going to get worse. And if I add to that, if you look at the urbanization trends, and now, unfortunately, we're also in the midst of something like 3 million refugees. It's a situation that's, pretty dire, and the approach that we're taking towards how things get built, and you've seen the presentations today on trying to move forward and do things differently, is actually, the pressures on all of us are only going to get worse. It was remarkable, really, when the world literally took a breather over the last 2 years. It's amazing how quickly nature reclaimed their rightful place. And the air quality in India, where I'm from, was staggeringly amazing, right? Within a couple of months, people in neighborhood could actually see the Himalayas. You could see the sky, and everybody, was enjoying a really, really good air quality. And my wife, who is currently in India, unfortunately, we're back, right? And everything is back to the good old or bad old ways, I guess. And I don't think we've learned anything. So, and of course, the planet, while we do what we do, is, as somebody said, it's shaking, baking, and flooding. And we aren't helping, right? So now that I've got you all depressed, let's talk about some good news. And with COP26 and governments and trying to get the transition to net zero, we're all frustrated as to how slow and how glacial the pace of change can be. What I find interesting and what I'd like to report is the trends that are happening with investors. You read about BlackRock, shareholders, activist shareholders getting on to, a big oil major board, forcing them to sign up for commitments. And not a day goes by that some other big, Fortune 500 company is making a public statement about their commitments. And in speaking to a few of them, I can tell you that, honestly speaking, nobody has any clue on how they're going to get there. At best, they write a check to a charity and plant some trees, right? So clearly, that's just not going to be good enough. And really, I've been doing some consulting over the last year and a half with some of these companies, trying to help understand their thought process, and then also try to help understand and then try to move them towards a mindset, frankly, especially with owners, on how to think differently about what they do, because quite often these owners are frankly the problem, because we all in the industry work for them, and they have, excuse me, CapEx groups and OpEx groups, and never shall twain meet. And it's going to take a different mindset from them to move us forward, frankly. The drive has to come from the owner. And then, because as I tell everybody, the gap between what we need and what we can afford is 15 trillion for infrastructure. It's 150 trillion, or some seriously large number, that Mark Carney and his team are trying to figure out if we're going to really go the decarbonization route, right? And this is one piece of that bigger puzzle. So changing the business model from the owner, it starts there. And new technology. I'm an optimist, right? Despite what I've spoken so far, I am a true optimist after spending 30-something years in the industry, and been around all the buzzwords and all the acronyms, and I sense the skepticism in the audience when I talk about digital twins. Like, here's another ploy to get software vendors to get you buy the new software. And it's certainly in the hype cycle. When the Financial Times writes about it, it's clearly reached some buzzword status. And I think what's interesting to me with this is the term digital twins, is pretty intuitive. You don't have to explain what that means. If I talk to my kids and they say, "What are you working on, Dad?" I say digital twins. I think most people have some intuitive idea of the analogies. Whereas if I said I'm working on BIM, they go, "Well, what's that?" And they try. The minute you have to explain the acronym, you've lost people, right? And then we could go back and argue about, hey, is CAD? I remember when I started my career, it was actually the days when people were doing things on paper, and then they were moving to CAD, right? CAD was taking stuff you did on paper and moving to CAD. And I was actually working at an engineering company that invested in those big workstations, $100,000 workstations. You remember those? And so this CFO and CEO decided to do a study a couple of years into it because they had to write a big check to see the impact of CAD on their profitability. And in those days, the way they measured the profitability was cost per sheet. You were doing a water treatment plant, you had a certain number of sheets, physical sheets of paper. They took the cost and then they divided by the number of sheets. And then the minute they did that, they did a few projects under their belt, they said, okay, we'll let you get trained, so now you're efficient. We'll measure it, a couple of years in. And guess what? The cost per sheet didn't go down. In some cases, it went up. And they said, well, listen, what's going on? And they found when they studied it, well, listen, the quality was much better, but also people were making changes all the way towards the end of the project because they could. If you were doing stuff on paper, you couldn't just make changes, right? If it was on CAD, you could, so all of a sudden, the question is, what are you measuring in terms of improvements? Was also something that, you need to sort of think about. So if we come back to the digital twins, the analogies that people can immediately latch onto is your health fitness trackers, right? Not a day goes by, and I would dare say that if you were in a live audience today, I would have asked for a show of hands. Maybe you can have a virtual show of hands of how many of you are using one of these. And I dare say most of us are. And some of us are using more than one, right? And we're getting real-time feedback on all sorts of data. And it's going to become even more interesting. I was reading about connected smart homes for retired people, and those of us who are elderly parents, would love to see a fully instrumented house where we can get feedback in real time that if an intervention needs to happen. So with that mindset, I just like to take a stretch into the same analogy to infrastructure. So think about infrastructure fitness trackers, right? Just a little step forward. And what you can imagine there are completely censored infrastructure that's emitting tons and tons of data that is then getting collected, because now with the cloud and sensors and Wi-Fi and all of this stuff, it's accessible. So it's absolutely happening all around us, right? And the question now is, all right, so if that's happening, why not just use the digital twin umbrella term and then move forward in a way that can help us all? As consulting companies here, you have new business opportunities to be able to go to an owner and say, hey, listen, we don't want to work for a billable hour, race to the bottom mindset. We want to work with you collectively, building smart infrastructure. And then perhaps even having a subscription model. And, Greg Bentley at Bentley Systems is always a deep believer in a new business model opportunity, inflecting upwards adoption of technology. So I want to spend, some time on really, the how, right? How are you doing? How would you get there? And I believe there's sort of three key enablers to think about, breaking through this mindset. And I'll start with the first is a data strategy. And I think Jennifer touched upon this as well. You have, I don't have to tell you, right? Your personal lives and your professional lives, the data is exploding. I just went back home. I was traveling for a little bit. I go back home and my NAS is fried because there was a power surge. Luckily, the NAS is, uploaded to the cloud. There's a cloud backup, and I'm trying to deal with all of that, and you've got redundant data systems. You've got unstructured and structured data. Every vendor is trying to sell you a CDE, so you probably have more than one. If you're an owner, I think you need to standardize on one. If you're a consulting company, you're hostage to projects, and so you're going to have to deal with many CDEs perhaps. But the whole idea is, it's 10 p.m. and do you know where your data is? What's the quality of it? What's the temporal elements of it? How quickly is it changing? How complete is it? And having a data strategy is a fundamental. I've heard, people using chief digital officer. There's an explosion of C labels in the industry, right? Chief digital officer, chief data officer, chief platform officer. But the whole idea that people are groping around is it doesn't matter what titles you give. If people don't wake up every day thinking about looking at data differently, we aren't going to get anywhere collectively. And it's just criminal to see how much of your data is locked up in and hostage to file formats, which is why we're all here together, right? Frankly, I think the other point I'd like to touch upon is sort of a systems approach mindset. And one of my favorite examples here to give is on my smart device, I had a completely separate and disconnected set of I had flight information from my Gmail, and there was traffic information from Google Maps, and I got notified saying, and the days that I was flying a lot, listen, traffic's building up. If you need to make your flight, you need to leave earlier, right? It was a proactive push notification to me, connecting two different silos, and I think that the complex issues with most of us as humans, if you start looking at it with instrumentation, is actually the interplay of different systems together. So if you have, as any organization, you have data silos, I think true insights will happen when you connect these silos together. And in order to do that, that's where standards come in, right? So you start with a data strategy, approach every silo with this mindset on how do I unlock this information? How do I store it, access it, wire it, orchestrate it to be timely, to be complete, and to have the quality? Because trust me, you want to fix quality at time of creation, not at time of handover, because the problems, it's too late to fix it. So every day when somebody checks in a file into your CDE, you should be having triggers, like in the software development mindset, where I came from. You compile your software every time you check in the source code, and that's how you keep your quality at the highest level. So if your people are working on engineering projects, every time you check in their work, you need to consistently, check for consistency. They're not just at 30% and 60% and get everybody into a room and see how the different trades interact, right? So talk about standards now. They're obviously the de facto standards that you're going to have to deal with, the XFCs and PDFs and everything else. And then importantly, the industry standards that people are evolving. And the challenge with all of that is the pace of development, right? So you've got to perhaps, realistically speaking, the next decade deal in a hybrid situation. But I think what's very, very interesting today is the ability to do stuff in open source, because you should have an open source mindset. It's amazing how quickly the world has changed on that front. I talk to my kids a lot who are, these days in the industry, and open source is just a mindset where when I was beginning, it was unheard of. Of course, security aside, I'm not being flippant about it. It is something to be very careful about. But having an open source underpinning strategy when you have to deal with data that's, the standards are opaque and maybe they haven't gotten to it, start with open source and then build with some flexibility, because then that will sort of keep all your options open. Because that's the ultimate promise for all of us is trying to, as I said, to go from hindsight, which is look at, if you're an owner today, you have so much data of your past projects. If you're a consulting company, you have so much data about your past projects, and you're struggling trying to figure out which ones were profitable and why, right? Maybe you can do it on a financial standpoint, but trying to do that on a look back basis and draw some machine learning insights from it, that's hindsight, right? Why things went wrong, or why were we particularly useful? And then, right, then you can get insights in your projects in real time. And then, of course, where we all want to get to is the predictive element, right? That you want to get predicted. You want to get told before a problem happens, either in your personal life or in your professional life. And the foresight is, there's a problem with this bridge or this piece of infrastructure, it's imminent collapse, or perhaps even it's in good shape, and your time-based maintenance can be deferred, right? Because it's the other approach can also be, we do everything on a time-based maintenance schedules versus data-driven predictive maintenance schedules. So this promise of moving from hindsight to foresight really underpins the whole digital twin promise, in my opinion, which is then predicated on having sort of the data strategy, having a systems approach of connecting all of these different CDEs together through an open source driven, standards driven mindset. So that's, as I said, I'm a true believer that you couple this with new business models that are owner driven, and we have a hope of making a change. And it is doable, right? I left India 35 years ago, and there were no, it took 2 years to get a landline. So some of you have heard this from me before over the years. It took 2 years to get a landline. And then when cell phones came along, landlines, who does landlines anymore, right? So there was a whole inflection, and they skipped a generation of how to do things. So I think the next generation of infrastructure professionals, hopefully, will have a whole brand new way of doing things that will be all underpinned under this technology. And that's what I think the digital twin promise is all about. Well, so if you have any questions, insights, I'd love to hear from you. As I said, this is my passion, and I speak to lots of people, and there's a lot of cynics and a lot of true believers as well. So be eager to listen and learn more from you. So thanks very much. Back to you guys.
Thank you, Bhupinder. I'd also like to invite Jennifer up, actually, if we have any questions from the audience or a couple of comments. So Jennifer, thank you for your presentation earlier as well. Appreciate that very much. And Bhupinder, yeah, thank you. And Bhupinder, that was very insightful as always. I think just a couple of comments from me, actually. Maybe firstly, Bhupinder, is that I do think there's an expectation from the next generation of, let's say, digital engineers, that digital twins and the technology will solve a lot of the challenges that are coming. And maybe they'll provide some answers through open source, or maybe it's just a necessity that will happen. But from what I can see, that there's definitely an expectation that they'll provide, or are we anticipating too much from them? Do we expect them to deliver too much? Are we sort of resolving all the problems will be solved by that next generation, or is that too much? I don't know.
Listen, idealism, sea change happens because kids, mine included, aren't constrained by the pragmatic elderly people, right? As I tell young kids when we'd hire them, the only reason I listen to new music is because of my kids. If it was up to me, I'd be listening to the same 70s bands, So change happens because of them. So the more ideal they are, the better it is for all of us, right? And they'll break the mold, they'll try something different, and I urge them to do that. Now, clearly, when you're building a nuclear plant, you want to be a little careful about what you break. Move quickly and break things mindset sometimes doesn't work, which is why there's a balance between, if you go to anybody, it's the seasoned people that will always tell you why they don't want to take change on their project. The big construction project guy doesn't want change on their project. And therefore, you've got to show them what's possible incrementally, right? Which is the other element of doing this stuff. If you come back and say it's going to have to retrain everybody, it's a disruptive change, all of those become friction in the system. So I think as you move forward here, trying to do it incrementally and is also, I think, a pretty important point.
But I think what you said earlier about business models. So you talk about the construction firm, but with small margins, they're kind of currently living project to project without actually using digital twins as a new business model to generate value through their work.
The sum of local optimization, right? It's the design, bid, build nightmare that everybody is now locally optimized and therefore the margins are squeezing and there's a race to the bottom, nobody can invest in technology. So therefore, if you say the design build arena is a place things are going to happen, modular construction is a place things are going to happen. So there'll be changes happening there. And as much of a owner-driven risk-sharing mindset that happens, right? It'll happen in Europe through these concessionaires, right? It'll happen through all the BlackRock and private equity owners of infrastruccer assets. They're going to take risk because they're going to have upside in running their, plants more efficiently. If these coal plants get shed off by somebody off their balance sheet because it's constraining them, and some private equity company buys them and they need to run it more efficiently and do carbon sequestration and stuff like that.
Mm-hmm.
You can show them a way to do it with digital twins, and if a consultant comes in with an innovative business model, they'll latch it up. So I think you'll see changes happening across certain industries, and then sharing best practices across them will be what I think we do.
Yeah, thank you. And Jennifer, so we'll talk about the next generation of engineers. How at Trimble do you look at your platform and then try to get the right balance between the next generation and then the existing experience that you already have at Trimble?
Yeah, I think like Bhupinder said, first of all, hello, everyone. I think, building a system for change and continuous learning, I think is extremely important, asking the right questions and always trying to do things better as opposed to, something that's been in an operating manual for many, many years. I think it's a different mindset. It's a growth mindset. It's a mindset of, we can always do better. And by the way, if you continue to do it the way you've been doing it, you're probably not addressing some of the emerging challenges that nobody has ever seen before. So I think as we build for the future, building for agility and change and embracing sort of the fresh mindsets, what you're learning in school today is completely different from what we learned. And I also have 3 boys. They come out of school asking questions on things that used to be the domain of a PhD in that field. There's just access to so much information, and the expectation is that people are sharing that information and bouncing off each other. And I think that's a very healthy mindset for growth moving forward. Trimble obviously has always been open to new ideas, has grown through acquisition. There's always fresh ideas out there, and bringing that into a large-scale global system, I think takes a little bit of science and a little bit of art. So,
do you think, there's a point made earlier, do you think that let's say the term of GIS and BIM, if one of your children said to you, Mum, what do you do? I work in GIS, then you have to explain what GIS is in the context of it all. Do you think that actually the term of digital twins, whether we like it or not, actually does break down some boundaries with people that aren't as fully vested in the community like we all are?
Well, I think there's different sort of ways to look at that. I think that the notion of a twin or having sort of multiple data sets in parallel is not a new notion for many of the young generation. I think prior, when we didn't have real-time communications, or we had to very laboriously look up data with a SQL query and a proprietary database, it was much harder. So I think there's lots of ways that people will resonate with a concept. I think, digital twin or metaverse or, a lot of these things are sort of refreshing the way that we look at concepts that have been developing over many, many years. I pretty much would predict that my kids don't know how to respond to what is a digital twin, but if you give them the concept of, constant iteration around sort of shared data sets, that is definitely a familiar concept to them.
Well, I used to build SimCity models when I was younger, and that's the early 2000s, so that's kind of a similar-ish thing, isn't it? But
yeah. The most real-time data they're getting is in their their player feeds for the real-time gaming. It is incredible what they can learn in the last 3 minutes of playing a massively multiplayer game.
Yeah. All right. Well, I'd like to thank you both very much for your time today, and we are a bit behind schedule, so apologise for that. And just to comment in the audience that actually building a digital twin ensure assets are more valuable. Large asset portfolio owners have started to realize that. So, and I think at buildingSMART, what we're starting to realize is that asset owners are starting to realize the value of that sort of data. So I think that's a really good point to end this digital twin session on. And we look forward to future sessions on digital twins. So Bhupinder and Jennifer, thank you very much for your time.
Take care.
Right, we'll move on to the next section of our final part of today's keynotes, which is around partnerships. So First up, we have a presentation from Herman Oogink from SCIA, who's going to talk about the SAF standard. So Herman, over to you.
Hello, my name is Herman Oogink and I'm going to present you the structural analysis format called SAF. I have been involved in this project from the beginning and I'm proud to be able to present it for this audience. Let me first explain where it all starts. At Nemetschek we started a project that was focusing on improving the workflow for engineering. It's a broad project and still ongoing. For that we interviewed many engineers around the globe. One of the findings was that engineers would like to have an easy to use exchange format for their analysis model. So we dived a bit deeper into that and found the next demands. Be able to check the analysis with other software without entering the whole model again. When there are complex models, they want to use tools to be able to create these shapes and need to be able to get that into their analysis software. Tools like, for instance, a grasshopper. Also, adjusting models via an easy format can speed up the design process. Be able to do checking of models after analysis with other available tools. For instance, do a connection design after you have analyzed your model. And be able to read in-cut embedded analysis models. Be able to read the in-cut embedded analysis model. Now they are only proprietary formats used. Based on this input, we created SAF, Structural Analysis Format. It is an easy to use format for all kinds of structures and can be used for exchanging models, but can also be used for creating models manual or via other dedicated tools, and it is based on a tool that all engineers love, and that is Excel. As said before, Nemetschek took the initiative, and to be more precise, it is SCIA who is leading this. But it is an open format and we encourage you all to join. It's not intended to make it a Nemetschek standard. Let us now look at the format itself. You see here the Excel layout, and each sheet in the Excel is an object type like beam, slabs, boundaries, etc. Each row is an instance, a specific element, and each column contributes or stands for an attribute. Let us look how the relation between the objects are defined. We have, for instance, an object node defined on a specific sheet called the structural point connection. These nodes have a name, and these names are used in the definition of structural curve members, structural surface members, and structural surface opening. Also for cross sections, we have a sheet where these object types are defined. Each cross section has a name. When defining the structural curve member, these names are used to refer. Material is also an object that has a name. This name is used in the definition of the cross section and via the cross section to the structural curve member. And it is used in the definition of the structural surface member. For the definition of the geometry of the curve members, we are using line, circular arcs, parabolic arcs, Bezier curves. Each member has a start and end node, and it needed intermediate nodes for instance, definition of a parabolic arc. Like you see here, this B3, we have N4 and N6 as start and end node, and we have a node N5 as intermediate node to define this parabolic arc. Bit similar is the definition of the geometry for surface members. The edges can be defined via a line, parabolic and circular arcs and Bezier curves, as you can see. Also here we start with defining the edge, start node N8 and end node N9. There is a line in between. And then we have, for instance, the other curve, which is a circular arc with a start node and an end node and an N11 as the intermediate node. Here is a non-realistic example containing all objects we have defined so far. And this we are using for testing. And I think it's not realistic, but I think it's a nice way to test the input and the export of the SAF model. Here an overview of all objects we already support. You see the analysis objects for defining the geometry, support and hinges, and also loads are defined, including load panels. In the latest release, we also have the internal forces on curved members available. This especially for external checks of, for instance, a steel connection. Let us now have a look at the geometry. Here you have an overview of all geometry of curved members and the edges of surface members, what we support. You see we have here lines, circular arcs, parabolic arc, Bezier, spline, circle and a polyline. This counts for the 1D, for the curved members, and also we use this for the edges of the surface members. We also support the curved members with varying cross-section. The beam is then separated in segments, and each segment has a cross-section at the beginning and at the end. Let us now let us look at the different cross-sections we support. We have the parametric shape, the compound shapes, the general cross-section defined by polygon, and the manufactured profile. Let us look at them one by one in more detail. The parametric cross-section we have defined in SAF, you see on the right side. You see all the shapes, and each shape has the parameters needed to define this shape. As you can see, it's a quite intensive list of possibilities. The same counts for the compound sections. The most common used paired sections are defined. The general cross-section definition is the most general one. As the name already is telling, here you can define each shape composed out of different materials and openings. So here you see, for instance, one material with opening, a cross-section with opening, and here you see, for instance, a concrete rectangle cross-section with a steel section inside. So really a composite cross-section what you are creating. Then we have the manufactured one. Initially you would say that is the most easiest one, but it isn't. The complexity is in the use of naming, which is not standardized, but also the definition of the local coordinate system that is used in the manufactured cross-section libraries by each software vendor. But only with an alignment of the local coordinate system we are not done. How the shape of, for instance, the T-section is defined in the vendor's library can be different. The flange at the top or at the bottom, for instance. Both ways are used. Or what with an L profile? How is that oriented in the local coordinate system by the vendors? To solve that, we invented the so-called form code that is defining the orientation. I will explain in the next slides a bit more in depth. Let us first have a look at the cross-sections. We have 8 possibilities and all are used. So here you see the picture with those 8 possible local coordinate system that can be used. Here you see an example where in the I section where we have the Z upwards and the Y in that direction. But all possible, the Z horizontal, Y down, etc. are used. In SAF, you have to tell which local coordinate system is used when writing to SAF. So the receiving party knows it and can act upon it. So one of the model data is how the local coordinate system is defined by the one who written that SAF file. The other topic is the orientation of the shape in the local coordinate system. As said before, some define a T with flange at the top and others with the flange at the bottom. Here you see, for instance, a T-beam, it could be defined like that, or it could be defined like that. For that we defined for all kind of shape and orientations a form code. If you see at this table here, we have here different form codes. In total, we have about 23 form codes defined. And you see for a T with the flange at the bottom, we use 6. For flange at the top, we use 9. The same for the L profiles, we have different numbers how those profiles are defined. We also thought about interaction with CAD system. Curved beams or walls, etc. are common in CAD system, but not all analysis software can handle that. For that, we introduced the possibility of having a curved wall as parent and divide it into straight segments that are charged from the parent curved wall. With that, we have a relation that can be kept, and in the analysis, the wall is calculated in segments. But we keep the relation with the curved wall in the CAD system. So if you want to do round tripping, that is secured in this way. Another development we did is making a software development kit available for vendors to be able to implement SAF in a fast and easy way. It's written in C# and available on GitHub. It covers automated unit and integration tests. It is already used by a lot of vendors who support SAF at the moment. So here you see the only thing you need to do is mapping your object to the SAF format, and the rest is automated. No worries about the Excel format, how that exactly should look like. That's all done by the software developer toolkit we created. Now the highlights of the SDK is that old and new versions are supported. It's up and downwards compatible. All objects validated. And we support metric and imperial units. And with the validation, I mean we are checking if the input is valid. Are you referring to a material, and is that material defined? Referring to a cross-section, is that cross-section defined, etc. We have the whole documentation online. Let us have a look at it. So here we see the documentation. So we have here what is SAF, who supports SAF. I will come back later to that, a complete table of all the suppliers who are supporting it. The SAF versions which are available. We have the release notes where we explain for each version what has been changed. We have the project and model data specification, how that looks like. And here you see the definition of those local coordinate system, which I mentioned before. We have then the curved members, for instance the curved member varying, it's defined how the attributes have to be defined. We have the surface structural edge connections, for instance, the boundaries, how we define them. We have here the loads defined. We have the curved action, we have a look at this one. And also the result, internal forces, which are already explained, that's quite new in it, for 1D elements, so that you have your internal forces available. Here we have the form codes. All the different form codes for all the shapes you can imagine. So we are coming to 23 form codes. And I think that's all I want to show you. You can go to it, it's saf.guide. It's available for everybody. Just click on it, go to the website, or just type in saf.guide and you can use it. Well, let me go back to my presentation. So here you see the companies who are supporting SAF. It's quite a lot already. There are some are implementing it. I think IDEA Statica already finished it. But Infograph and also D are currently working on it. And we are currently in discussions with other companies, with other suppliers to get them on board. So how do we work? Now, we use GitHub and Microsoft Teams for communication. We have a general chat for all participants, so if we want to discuss something in general, but we also have a one-to-one chat for implementers when they are dealing with a specific issue topic which is really only relevant for them, they can get in contact with us and we can help them. Yeah, we are collecting the new demands and we do voting, and the collecting demand, it's coming from wishes from all the participants. Then we collect them and we do voting. So and based on that voting, our priorities are defined. Then normally we will come up with the specification, so we make a first draft and ask others to comment on it. If we finally all agree, we make the final definition and put it into the SAF documentation. We adopt the open source SDK and also use it internally to test it. And then we collect the feedback and adjust if needed. Now, last thing to mention, that is the versioning. So from version 2.0 on, we started with semantic versioning. Before 2.0, it was not that strict, and that's not okay. So from 2.0, we do it in a formal way, where we have 3 numbers. The first one is the major number, and that means that number only increases when there is no backwards when there is a backwards incompatibility. The minor one we will use when we have new objects, but it is not hurting the compatibility. And patches, I use this number if we do bug fixing. Then we increase that number. So if you want to join, and of course we hope to get as much as possible people who joining this initiative, and you can go to the documentation, which saf.guide, which is on the internet, and you can use the link in the documentation to go to GitHub, where we can start the discussions. To be honest, on GitHub there is not that much discussions ongoing. Mostly it's done through Microsoft Teams, but we are trying to get the people all involved in this GitHub so that all the discussions are there centralized together. And once more, hope to get you all on board to help the engineering world improving their workflows. Thank you for your attention.
Well, thank you, Herman. And indeed, improving the workflows is the purpose, isn't it, here? And it sounds like a really interesting standard. So do encourage people to check it out on GitHub. Thank you very much. Next up, we have a presentation from Joseph Ickmans from Efca. Efca and buildingSMART have started to collaborate. And I think, Joseph, you're going to expand on that a little bit and talk about some of the collaboration work that we're doing, as well as a bit of an introduction to Efca as well. So, yeah, over to you.
Yes, thank you very much, Aidan. Can you hear me correct? Yeah.
Loud and clear, yeah.
Okay, great. Well, first of all, also from my side, a warm welcome to everybody who is watching this. My name is Joseph Ickmans. I'm the chairman of the Digitalization and BIM Committee at Efca, which is the European Federation of Engineering Consultancy Associations. And I'm really enthusiastic, and not only me, the whole committee is enthusiastic about this collaboration with buildingSMART International. But like Aidan said, let me first tell you a bit about Efca. What is Efca? Well, first of all, it's the only association representing the engineering consultancy industry in Europe. We have 29 FIDIC national associations that are represented in our organization of Efca, and Efca also represents FIDIC in Europe. So at this moment there is, for example, a collaboration agreement that is inactive from 2020 till 2024. So what does Efca do? I try to summarize it in 3 main topics. First of all, it's to positively influence EU legislation that impacts on the engineering consultancy business. We are very much into promoting fair competition and transparent procurement rules. And the third one, of course, is to create a network and a business platform for our member associations and European firms. And well, we don't do that alone. We do have a cooperation with other organizations like ACE, the Architects Council of Europe, FECO, European Federation of Management Consultancy Associations, FIEC, European Construction Industry Federation, and EIC, European International Contractors. And Efca itself, it's divided in several committees and working groups on very specific topics. So we have an internal market committee, we have a European External Action Committee, of course, digitalization and BIM committee that I'm chairing, the European Green Deal Committee, and we also have some working groups like Industry Barometer, Future Trends, etc. You see them here that are all active at this moment. So that about Efca in general. Let's come to the heart of our discussion or our presentation. Is why to collaborate. And first, maybe have a short introduction on the committee that we have ourselves within Efca, which is the Digitalization and BIM Committee. As said, we do have representatives of 29 European countries active in our committee, and I summed up a bit the main topics that we are active in within this committee. First point, our first objective is to inform and to share information on digitalization and BIM development. So a lot is happening, and it's happening faster and faster these last years. So we do try to monitor what's happening around us, what's happening regarding CEN TC 442, ISO TC 59. We do have a connection with the EU BIM Task Group. Some of our members are also connected to buildingSMART International already. So we have our antennas in the world of digitalization, and we share information. And it's not only about what's happening in external committees, but it's also what's happening on a national level. We are a European organization, and as you can imagine, legislation and habits are quite different between countries. And that's really something that is extremely interesting to discuss about and to find a common ground. Second objective for us is also to organize debate and action on Efca recommendations, and to positively influence legislation or the policymakers, and that both at a national and European level. For example, we have written a position paper together with ACE, the Architects Council of Europe, on software providers. There was, maybe some of you know, there was a paper composed by FIEC on certain worries about software development. And so we also have a position on that. A third point, and this is something which we are very proud of, we also helped to develop the European Industry Policy Statement. We participated on the DigiPlace project, and this is specifically on the use of common data environments and cloud services. And of course, from our side, bringing then special focus to issues related to security, financial concerns, economic sustainability, classification, data ownership, transfer, access, user and storage rights, and regulation. So this project is now finalized, but maybe there will be a sequel to that project in the near future. And a last goal for our team is to promote and support digitalization towards our members. All of us in the committee, we are very, very enthusiastic about digitalization, and of course it's necessary to share our knowledge and our findings together with our national organizations and partners. So, for example, we have written a booklet on the ISO 19650 from a project management perspective. Okay, so again, why collaborate? Why collaborate with buildingSMART International? Maybe first have to explain a bit about engineering itself and why it's so important for us, such a collaboration. First of all, as engineers, we are involved in the whole construction process from feasibility phase up to operational and maintenance phase. And this is covering different aspects. It's about technical management and design, which is most of the time the first thing everybody think about if they talk about engineering. It's technical specifications, models, scope of works that need to be composed. Of course, everybody knows us for being very active in that field, but it's not only that. It's also project management. It's environment management. Everything related to permitting, for example. It's becoming more and more of a challenge in our countries, and clients are looking to us to deal with that along the whole way. So a fourth point is also quality and project control. And of course, BIM fits into that, I would say, but not only building information modeling, but also systems or processes that help control your project, like systems engineering. And what we often are faced with is to set up the organization or the structure to get all these different processes, tools working together. As you can imagine, it can be in some complex projects and some big infrastructure projects. It can be really a challenge to get 10 or 20 different platforms, cloud solutions, software applications to work together in a good way. And last but not least, it's contract management. We are also involved in setting up procurement. Of course, the end responsibility there is always with the client, but we prepare the specifications, both commercially as technically. We do bid comparisons, so we are active along the whole way. And I would say, although in this whole digitalization, we are not maybe the partner that is picking all the fruits of the labor or having the most of benefit of digitalization, but we are very innovative, and we maybe also a bit of idealists on this, and we are actually pushing digitalization in the construction industry. You see in some countries where you don't have an obligation of doing BIM, you see often that it's contractors and engineers that are really pushing the digitalization in that countries. And the last point, also very important, we work for clients, we work for the business, and we assist the business to control that digital future and also a greener circular economy. Many of our clients also are very wary about the fact that our climate is changing, and they are very actively pushing towards that greener circular economy. And we think that for achieving that, it's important to have a digitalization. And in our case, we prefer open standard digitalization because it makes things comparable also. And yeah, of course, all of you present know much more about buildingSMART than me, but so it's maybe not up to me to put this slide in here, but just to have the comparison. But in buildingSMART, it's all about developing and providing open standards, of course, and developing also technology for those open standards, supporting the exchange requirements along the whole life cycle of assets and works. And Open BIM, I put it here because it's so important for us. It means it's a neutral approach. It's neutral approach on several things. It's on data, and information to be shared. It's also on neutral approach on the process, on how to share that information. It's about neutral IDS. And it's at the same time also make sure that you have a single source of information for comparing performance. Specifically, if we talk about a greener circular economy, make comparison between different solutions, it's very important. And we do believe that open standards play a vital role in that. And all in all, I can say it's about providing workable standards by extended knowledge on both ICT and the business. So why then collaborate? I think I gave the hints, but we as engineering consultants, I think I demonstrated that we do have an extended knowledge on processes and risks. Not only the process, also the risk. We know the business, we know what can go wrong. We are already in this digitalization for so many years, and we see so many failures also. We know where it can hurt and where it can prevent us from building up a good system and a good open standard system. So I think we do have knowledge to share there. And we also, from our side, we have a need for workable open standards. Workable open standards, first of all, of course, to prevent monopolies in software provisions. Also for guaranteeing data accessibility, which is very important in infrastructure projects, specifically where we talk about a lifespan of 50 or even 100 years. So you do want your data to be accessible in so many years after you have constructed your asset. And like I said before, but I repeat it again, open standards to make sure that you have a decent comparison between different solutions. So for us, it's our collaboration. We see that more as aligning open standard developments with the business. We can help there with our knowledge on the business. And it's also to assist in the mitigation of risks regarding the digitalization, because digitalization, it brings with it also a change of processes, of responsibilities, of contracts, etc. We need to deal with that. Do we wish to have a workable solution for open standards in general? And I think if we succeed in that, and I'm very enthusiastic about that, is that we can work all together towards a greener and sustainable future with open data at its core. So my last slide is, okay, what next steps do we have we foreseen? So we are now in the process of making a position paper or an MOU. And we also have already some thoughts about how to practically work together. I put here 4 bullets, but it's not an exhaustive list. It's still to be discussed. But one of the things, of course, I've said it before, is being closely involved in as we are being closely involved in the complete construction process, is provide guidance on the needs of the construction business. That's the first thing. I think we can also be involved in various processes of certification that is developed by buildingSMART International, for example, validation by Efca on processes. We could be involved in the process of creation, review, and prioritization of the use case management system. And last point, which for us, I think is a very important one, it's that we could join forces regarding making proposals for implementation of these open standards in contractual documents. And we see that maybe in first instance for the European Commission and for FIDEC, where we can maybe put up some standard texts that is capable of, that people can use and that clients can use, and that clears out all the myths and do's and don'ts for working with open standards. And I think that's really something that can be useful to share with clients that are interested to go this route. So that's it for me. If you want to know some more about our organization, Efca, please do have a look at our website. And should you have some more questions, you can reach us at the email address written here below or via telephone number. So that's it for me, Aidan. Back to you.
Thank you, Joseph. I must say it's been a real pleasure actually to work with you so far, and I really look forward to the next steps actually in developing this with your organisation. And yeah, thank you very much for today as well. It's great to have some insights from you, and look forward to the collaboration.
Thank you. Pleasure.
Thank you. Right, we're up to our final speaker for today. Certainly been an interesting day, and it's always really nice to hear from Neil and the Open Design Alliance. I have to say, if anyone hasn't checked out their website, it's very cool, and there's always a hell of a lot of interesting new things coming out of ODA. They seem to adopt things and innovate really quickly. So can't help but bring them back to see what's happened in the last 6 months. Is always amazed. And with that, I would like to hand over to Neil Petersen, who is the president of the Open Design Alliance, who's going to give us an update on some progress that's happened at the ODA. So over to you, Neil.
Greetings, my name is Neil Petersen, and I'm the president of Open Design Alliance. ODA is a technology consortium that provides complete interoperability solutions for CAD and BIM. We're also an official buildingSMART partner. Our primary open BIM technology is our IFC SDK, which is a full-featured developer toolkit that allows high-quality IFC support to be integrated into any application on any platform. ODA IFC technology is being used by a wide range of major vendors, including Autodesk, Bentley Systems, Esri, and many others. Today, I'd like to share with you some of our recent advancements in OpenBIM broken down into the following areas: core IFC technology, Exchange with proprietary formats such as Revit and DWG, validation, and visualization. At the end, I'll also talk about some other interesting projects going on at ODA right now. One of our goals is to support the entire IFC feature set, and to do this, we've developed our own Express interpreter. The Express interpreter allows us to parse any version of IFC given the schema file for that version. It also includes sophisticated IFC constructs, including express functions, derived attributes, where rules, and global rules. Our Express interpreter makes IFC SDK the tool of choice for serious and sophisticated IFC users. In addition, we're looking to harmonize the implementation of our IFC SDK with our new STEP SDK, which I'll talk about a bit later. IFC and STEP are both Express-based formats, and we're developing a set of debugging tools which will improve the usability of the interpreter and support complex manipulations over schemas. In addition to the interpreter, we've written our own Express compiler that can generate C++ code for any Express schema. We use the compiler internally, not only for C++ code generation, but also for automatic documentation generation for our early bound IFC API, which is used by a number of ODA members. For established IFC schemas, we have a set of predefined classes generated by the Express compiler. But clients also have the option of immediately working with any new IFC schema using our Express interpreter and dynamic interface. You don't have to wait for a new ODA release. You can just download the most recent Express schema file from the BSI website, and you can start working with the new version directly using SDAI. Our generated code is 20% faster than this dynamic approach, so we provide both options for our clients. We offer source code licensing options as well, so clients are free to customize and adapt this advanced technology for their own needs. Basic editing of IFC models is a popular feature request from ODA members, including the ability to safely delete elements from a model and the ability to copy and paste elements within a model or across multiple models. Often a user will want to tweak a model slightly, And without the ability to edit the IFC directly, you have to go back to the original application that generated the IFC file, make changes to the source model, and regenerate the IFC. For minor changes, this can be an inefficient process. To address this issue, ODA is implementing basic editing support for IFC, including the ability to remove, clone, and create IFC elements. In this short demo, we select an element in a model and choose clone, and the selected object is copied into a different model. The full subtree for the cloned element is included, and this functionality is currently available in beta and will be available for production use in June of this year. In addition to being included in our SDK, it will be available as a standard end-user feature in our Open IFC viewer. We've made significant improvements to visualization of IFC alignment elements for IFC 4.3 Release Candidate 4. We now support all new curve types required for vertical, horizontal, and cant alignments based on polynomial spirals and polynomial curves, as well as visualization of appropriate sweeps in accordance to railroad inclination. You can see some examples of these new curve types in this screenshot. Another interesting client request is for an automatic or semi-automatic method for populating property and quantity sets within an IFC model. To address this issue, we will be developing a new PSD QTO engine to facilitate the creation of property sets and quantity takeoffs from XML-based PSD QTO definitions. Finally, we can now read IFC JSON, which is a text-based encoding of IFC based on JSON, a common standard for transmitting data in web applications. ODA recently released standalone export from Revit to IFC. IFC export is a feature of BIM-RV, our standalone toolkit for working with Revit files. Using BIM-RV, you can load a Revit file into any application, access the Revit data programmatically, and also visualize the model. With the addition of our IFC export feature, you can now also export any Revit file to IFC. Using this technology, you can take a Revit file stored on a cloud server, for example, and convert it to IFC without any dependencies on the native Revit application. Our technology is cross-platform, so you can run this conversion on Windows, Linux, or Mac. Currently, we support full export from Revit to IFC 2x3, with IFC 4.0 support coming soon. A number of customization options are available, such as the ability to export only elements that are visible in Revit, or a set of elements selected by level or type. The export can optionally include IFC properties, common property sets, and quantities. Another common request from our customers is the ability to convert IFC geometry to DWG, the native format of AutoCAD and a de facto industry exchange standard. Our latest IFC SDK can export the geometry from an IFC model to DWG. DWG is supported by a broad range of applications, so this provides an easy method for loading an IFC model into applications that don't support IFC directly. Here you can see an example of an IFC 4.2 model of a bridge that's been converted to DWG and then opened in a native DWG-based application. In addition, we can import DWG geometry into an IFC model. There's a strong industry need for tools to validate IFC models. ODA released a validation engine for IFC last year, and we made validation a standard feature in our free Open IFC viewer. Our validation engine incorporates an early version of the new IDS standard from BSI. IDS, or Information Delivery Specification, defines the requirements for the exchange of BIM data. IDS is still under development by BSI, and we'll be updating our validation engine to use new versions of IDS as they're published by the IDS working group at buildingSMART. In addition to IDS, ODA has also recently added support for MVD XML. A model view definition, or MVD, defines a subset of the IFC schema that is needed to satisfy one or more exchange requirements. MVDs are encoded in a format called MVD XML, and they define the allowable values at particular attributes of particular data types. MVD-XML is often used to customize the export of IFC data. It's an older specification that was first published in 2013, but it's still in use today and is quite popular with some companies. ODA has implemented an initial version of MVD-XML support that includes an API for reading, accessing, updating, and writing MVD-XML data, and support for interpretable expressions. Currently, there are incompatibilities among various commercial implementations of MVD-XML. ODA is working to provide a full implementation of MVD-XML that supports sophisticated export of IFC data using a mechanism that can be standardized industry-wide. We'll be adapting our IFC export from Revit to use MVD-XML later this year. OpenIFC Viewer is ODA's free viewer for IFC files. It's available for Windows and Mac, with a Linux version coming later this year. It's based on our IFC SDK and Visualize SDK, and it's proven to be quite popular with nearly 500 downloads per week. We've made a number of improvements to OpenIFC Viewer. The first is better visual fidelity. We use a technique called Screen Space Ambient Occlusion, or SSAO, to simulate the effects of ambient lighting in a scene. SSAO makes a scene look realistic by adding subtle shadows in the corners and around the edges of objects. We've improved our SSAO support significantly since last year, and you won't notice this difference dramatically if you open a file in our latest viewer, but the scene will look better, more realistic. Second improvement is more sophisticated inspection of collisions connected with our BCF support. You can see in this example, when you click on a collision, the offending objects are now displayed in blue and red against the rest of the model that has been faded and made transparent, so you can more accurately see the context of a collision. Another significant improvement is the addition of a plugin framework for the viewer. We often get requests from customers who want to customize the viewer in some manner. The new plugin framework provides a clean and modular interface for adding new features. We're using plugins now to implement the BCF manager and the validation component of the viewer. We have a new model statistics plugin available from the context menu by right-clicking on a model that shows instant counts by element type for the model. A new tree view plugin is a powerful tool for IFC model investigation. It allows navigation among a model in tree view form, and it's possible to open several trees simultaneously. Tree view is available from the context menu by right-clicking on any node in the Object Explorer tree that has an underlying IFC instance. I would encourage anyone who needs a customizable, professional-grade IFC viewer to check out openifcviewer.com. Full source code for the viewer is available to all ODA members. As a not-for-profit professional software development organization, ODA is the leader in toolkits for open standards. We're an industry partner that develops high-quality solutions for the long term. In addition to IFC, we now support STEP, the open standard for mechanical CAD. Both IFC and STEP SDKs are based on the same SDAI implementation by ODA, so data from both formats is available using the same ISO, SDAI, or C++ APIs. We released a beta version of our new STEP SDK in December of last year, and the current version already has enough functionality for creation of any desirable STEP model, including AP203, AP214, AP238, and the latest AP242. By the end of this year, we'll have full production support for STEP, including data access, editing support, geometry visualization, and the ability to do combined visualization of STEP and IFC models. STEP and IFC can also be combined with other ODA-supported formats, including DWG, Revit, Navisworks, and DGN. Clash detection can be done on the combined model, and you can also export the combined model to 2D or 3D PDF or to Navisworks. LandXML is an open standard used for the exchange of civil and survey data, including points, alignments, roadways, parcels, and more. We've recently started work on a new LandXML SDK, and we'll be releasing a beta version in June that supports read and write access. By the end of this year, we'll have a full production release for LandXML that includes visualization support. In January of this year, ODA started work on a new Scan-to-BIM project. Scan-to-BIM is the process of taking point cloud data generated by laser scanners and converting that data into IFC or Revit BIM models. Laser scanning is a standard technology today, used for renovation projects and new construction. Scanning technology has advanced rapidly, but our ability to efficiently work with the point cloud data generated by modern scanners hasn't kept up with the latest scanning advancements. There are a lot of Scan-to-BIM services available today, but they tend to be expensive and they require a significant amount of manual effort to achieve a result. ODA would like to democratize Scan-to-BIM. We're developing a toolkit that will convert point cloud data to IFC or Revit, with the goal being a fully automated process, or as close to that as possible. The project is being funded by a group of major industry vendors, and the result of the work will be made available to the broader industry. Our Scan-to-BIM SDK will be economical and accessible. Our vision is that Scan-to-BIM should be a standard technology that can be integrated into any application on any platform. If an iPad generates a point cloud from a scan, our technology will allow that point cloud to be converted to a BIM model in real time, opening up a lot of new possibilities for application developers. The project is currently funded by a dozen industry vendors, and we're seeking additional partners. It's an interesting and challenging project from a technology point of view, and it's also a valuable and much needed service for the broader industry. If you're interested in Scan-to-BIM, please join us. You can find out more about our Scan-to-BIM project at opendesign.com. Thank you for your attention, and I'd like to thank buildingSMART for the opportunity to speak with you and to share our message. If you'd like to discuss any of the topics I've talked about today, feel free to contact me at president@opendesign.com.
Well, as I mentioned earlier, I'm always very impressed with the work done at the ODA, so thank you, Neil, again for your very good update. Well, we have come to the end of our day. Just to sort of recap, I think, before we conclude today. Sorry, we're a little over schedule, but often happens despite our best efforts. But so, firstly, I'd like to thank all of our speakers today for your many contributions, and to our attendees for coming and spending their day and their time to listen to some of the content we've had. And we started today with some of the opening keynotes. We heard from Patrick and Richard Petrie, Richard Kelly, Leon, Mark Baldwin, Thomas and Anna Moreno from the Italian chapter. We then moved into bringing Open BIM workflows to life, where we also heard from Leon again and Michelangelo Cianciulli from ICA and Calvin Cam from SBI to look at some of the workflows that are in practice today, which I think was fascinating. We also heard from various speakers on sustainability and standards. We heard from Lai Wei from China. We heard from Fiona Quick from Siemens and Bertrand Lac from Schneider talking about sustainable energy management, and Christophe Gastin on low carbon strategies. We then heard from some of the projects of IFC 4.3. We also heard from occupant movement analysis and IFC tunnel and FM to Open BIM projects as well, respectively. And we've just concluded on digital twins and partnerships, and a presentation from Jennifer Lin from Trimble, Bhupinder Singh from InTwin Insights, Herman Oogink from SCIA, and Joseph Ickmans from Efca, and just finally Neil Petersen from the ODA. So lots of speakers, lots of content. We will start tomorrow's session with room presentations at 8:30 in the morning. If you missed anything from today, there is a replay function located in the platform. Of course, we do also encourage anyone to interact with other members of the audience and provide any feedback to buildingSMART International about your experience so far. So with that, once again, I'd like to thank you all very much for your time today, and we look forward to another productive day tomorrow. We'll start with room sessions. So thank you all very much, and we'll see you all tomorrow.